not much time. So did you get a feel that the majority of the material you were familiar with, you had seen it, it didn't look as Greek as the first time? Yes, maybe? But it was still hard. What was hard about it? What particular topics did you think were hard or difficult? Or?
I think these exam, couple of, I still get confused when I read the exam, but actually which formula to use.
Okay.
My problem is that. So I do understand control chart chapters when I read, but when it comes to the example,
that's the hard part.
Confused which one I should use, and I get lost in that.
Yeah, that's the hard part, right? This is an open book, open notes question. So the answer you're probably going to physically have with you. It's a matter of can you figure out what the question is asking you, and can you properly apply it? That's what it's really.
And I think I need to work more with my books, with these guys, work with us.
Yeah, absolutely. On the exam, you need to be taking this as realistically as you're going to on the actual exam in June, the first weekend of June. You need to take it like you're going to play. You need to practice what you're going to play. Any questions for me, procedural stuff, before we start digging in? Okay, I guess we'll just dive right in. I didn't send out the answer key, but I'll send it out after class. Where's everyone?
I don't know. Where everyone?
No, this table. This table isn't here.
On the microphone. On the micro came because we asked each other. So
yeah, so I guess everyone just wants to watch the videos, which I said everyone got the playlist now. You don't have to go back through and find all the links. I said put it all in one YouTube playlist.
I didn't open it.
Okay.
I saved your
Okay, so I tried to make it a little easier for you. I put everything into one YouTube playlist so you can actually just select the video.
Can I ask you a question?
Yep.
We have this CD, we have this book, right?
Yep, CD in the book. What's on it?
How that will help? Like if you just.
Okay, you have already done most of the material in the CD from the book. The CD from the book, one of the great resources is practice exams. And in my infinite wisdom and my theft, the practice exams that you've taken, a lot of the questions are directly lifted from there. There's also some additional slides on there. Some of them are kind of funny. They're just supplemental slides. Not worth really looking at that much. I co-opted a couple of them when they were good. Otherwise, you can just flip through them. They're just supplemental, but the practice questions are basically lifted from the CD.
So it's like how much duration, like 1 hour, 2 hours?
Well, it's the practice exam, so there's about 150 questions.
Okay.
And then the extra slides there's like 20 extra slides.
Okay. So I think we have to stick that in and take a look at it.
Yeah. You
You
carried it around. You can also use it to throw at your neighbors, throw it over the cube at someone. You can put it through the autoclave to see how it's going to melt. I think that'd be pretty cool.
And we can like scratch the printout, and then we can heat up, and then you blow it in with a solution.
Just write the titles.
Okay. Okay, so without further ado, shall we begin? Maybe? Okay, a sampling plan where each item is treated as a sample of one in determining to accept, reject, or continue is called. Well, let's go through the ones of these that actually are something. So stratified. Stratified sampling is the process by which you de-randomize your population. So in a randomized sample, each and every individual from the population has the same chance of being selected. In stratified sampling, you want to group them for some reason. So if you want to stratify the electorate, you might want to poll men and women. And you want to poll them in such a fashion that your ultimate sample is comprised of what your electorate is. So if 55% of men vote and 45% of women vote, you want to make it such that your sample is 55% men, 45% women. That's an example of stratification. Double sampling plan is an example of a sequential sampling plan. So double sampling is one case of sequential sampling. And sequential sampling is exactly what we have here, where first you take your first sample, and you can do one of three things. You can accept your lot, you can reject your lot, or you can do more sampling. And sort of what you do intuitively is that if you get something that you're not quite sure of, you go and collect more information. So if you get a really good sample, you know you're good. If you get a really bad sample, you know you're bad. If you're somewhere in between, you want to get more information. And as we talked about in control charts, and as we talked about hypothesis testing, And as we'll talk about confidence intervals, the more information you have, the better. The more you know, the more you know. And that's sort of encapsulated here. Okay, so our answer there was D, sequential sampling plan. If you put double sampling plan, you're on the right track, but sequential sampling is a better answer because double sampling is a type of sequential sampling.
This book doesn't describe the double sampling.
Yeah. Also, that's something you should be familiar with, is that there will be questions on the exam. There will be terms and phrases that are not necessarily in this book. The exam is comprised of information from about 8 different reference materials. This is one. I happen to think it's the best. But don't be thrown. There will be about 3 red herring questions on the exam. That will be something completely you haven't seen. Hopefully it's not radar charts this year, because we'll have covered them this year and you'll be familiar with what radar charts are. But it's been radar charts in the past. And now it's happened twice, so it's now in the stuff I go over. Okay, a survey asks for area code that is used for demographic analysis. This is an example of what type of measurement scale. Okay, so let's go through each of these. Nominal. Nominal groups things into categories where there's not a numeric relationship. Ordinal puts things into order, first, second, third, fourth. Interval. Interval and ratio are very similar. Ratio being that there's a rational 0. Okay. So what do we have here? 972 is Dallas, Texas. 973 is North Jersey. There's one number off. Does that mean anything? No. But if you want to do it this way, you're grouping things into geographic categories. So nominal, right? Cool. 3, which tool in its simplest form makes the data collection process easier? Check sheets, yes. Remember that Brandon doesn't like check sheets because he thinks that they're non-value added, but for the purposes of this exam, data is collected on check sheets. 3 questions in, those are pretty easy, right? Pretty straightforward. I was concerned to say things are easy. Okay, when quantifying a process capability, the primary difference between CP and CPK is what do we think? Okay, so do we remember what the formulas are for CP versus CPK?
I think both is very close, B and C.
Okay, so let's start with the formulas, right? What the definitions are. So process capability is an index that represents the probability of producing something that's going to satisfy your customer, right? CPK and CP. Okay. This helps us start by writing the formula, just so you know where you're going. So for CPK, it's the min of the upper specification limit minus the average over 3 sigma, or the average minus the lower specification limit minus 3 sigma. That's CPK. And then CP is the upper specification limit minus the lower specification limit over 6 sigma. And we spent a good deal of time when we introduced this to understand the difference. In the case of, and what is the difference?
CP is basically telling you that the process is under control.
Actually, it is.
But CPK will tell you how
it's other
how
opposite from the mean, but that tells you for CPK that falls in the.
That's what I said.
That's CP.
No, CP says your process is under control.
No, control relates to control terms. The only way you know that your process is in control is with control term. Both CP and CPK are indexes for your process capability. Process capability is relating the voice of the process, which is your sigma level, right? And your voice of the customer, which is your specification limits. But if you look at the formulas there, so in both cases we have an upper spec limit, we have our standard deviation. We have our lower specification limit, we have our standard deviation. But in CPK, we have to know where the mean is. And if you remember that, when you draw out the two, so we have our lower spec, our upper spec, and we have our process distribution, right? So if we're centered in, if our process is centered in our upper and lower specification limits, CP and CPK will be the same. But if we take a case where we have our, those are supposed to be the same. So these will have the same standard deviations, right? So our CP value in these cases will be the same. Everybody see that? If this sigma equals 3 and sigma equals 3, let's go through here. Our upper and lower specifications, did they change? Did sigma change? So these will give you the same CP value. But will we be producing the same number of bad pieces for our customer in these cases? No, right? Here will be pretty good, right? Most of the product we'll be producing will be here. Yeah, not so much. Only put this a little bit too. So, but we'll have this CP will give us the same value. So it's a pretty good index in that case, right? Whereas if we were to go with our CPK value, which one would have a higher CPK value? Let's see this guy right. This CPK would probably be negative because our average is less than our lower specification. Everyone see that? Okay, now that we've talked about that, what do we think the answer is? C, right? Is a measure of potential capability. So C is the best case scenario. You happen to be right in the middle of your spec limits. How reasonable that is? Yeah, not really that reasonable. Because again, these are two independent things. Your customer wants what it wants, well, because it's well the customer. Your process is what your process is due to natural variation or however it was designed. If you have two independent things, why is one going to be perfectly centered relative to the other? Seems kind of unlikely, but it occasionally happens. So 5.
So when you go to number B in the option, right? So if you look at the ratio of engineering tolerance, that is like CPK actually doing that.
They both do it. They both do it. So they both relate the engineering tolerance, the upper and lower specification limits, to the process distribution, that's the standard deviation. The main difference is that CPK has this idea of the mean and compares where the mean is relative to the limits. So CP
is both answer correct?
Oh, no.
No.
I can see this one.
B is because we're seeing how they're different. And in B, they're the same. They both have that attribute, that they're both related.
Right.
It's a correct statement about both of them. In the case of C, CP is more a measurement of potential capability, right? It's the best, it's the highest value. CP always has to be greater than or equal to CPK. So that's why the answer is C for number 4. 5, staying in the theme of CPK. If the upper and lower specification limits are set to 6 sigma, the process capability CP is 2, and the process capability index, CPK, is 1.5. What do we think? It's actually nice. Did anyone find this in the book?
I didn't find this in the book, but I did not remember. It's 3.4 difference.
Yes, it's 3.4. Yeah. So this was a find a word question.
Yeah, I found it somewhere, but I forgot to write the number.
Yep. Yeah, there's a nice little table in the book that says your Six Sigma process if you meet these criteria.
So you're going by the graph.
This is more of a, we can go through the math of the definition, but you should be familiar with that table on 218. Yeah, that. Yeah. Okay, moving on to question 6. So the answer there was D. Moving on to question 6. The most useful measure of averages for the nominal measurement scale is the yellow, blue. How do you take the mean?
Sorry, more.
Yes.
It must be then.
Yes. Yeah.
This is what you said. You gave us that answer.
Yes. I emphasize this one a lot. So the most useful measurement there is the mode. You should be familiar with generally for ordinal data. The best measure of central tendency is generally the median for ordinal. For ratio or interval, generally it's the mean. Generally speaking, I would be absolutely shocked in June if you don't see a question that is which is the best measure of central tendency for one of those data sets. So nominal, mode, ordinal, median. Everything else, mean.
Can you repeat that?
Yep.
Ordinal is median.
Yep. Nominal is mode, and ratio or interval is mean. It doesn't get it gets a timeout. Supposed to get the second timeout because they were mean. Okay, 2 of you thought that was remotely funny. I thought that was funny. Tough crowd. I'm to you guys for 2 weeks and you stop laughing at my jokes. 7, an engineer reviews a control chart and finds a pattern that shows an indication of a mixture. An explanation of this pattern may be what do we think?
No, I said the last answer, both B and C.
B and C?
The last answer, B.
Oh, yeah, that makes sense. Special cause
Because it says mixture. So it could be-
Yeah,
I don't know.
let's all agree that C is right. So the answer C is absolutely right. As it relates to question B, option B, the author of the question says that it's a misuse of the control chart, and therefore it can't indicate special cause variation because it's not special in that case. So the credited answer here was C. If you put B and C, option D, I'm very sympathetic because that's actually the answer I put. But the credited answer here is C.
Yeah, because it's very close.
It's a close call. The technical answer here is if you have a mixture, you can't detect for special cause variation with it because you're not using the tool correctly. So any result that you get from the tool isn't going to be bad because you started from a bad place. The correct answer is C. And if you put B and C, option D, I was in the same camp. And remember, you don't need a perfect paper on this. You need a 76. Okay. 8. The different measures for central tendency include which of the following? Yes, B. The mean, the median, and the mode. Beating you over the head with that one, Yish. Should be good with that one. Okay, the stem and leaf plot is a text-based analysis of data that is similar to the histogram. Yep.
I said this is program just because the stem and leaf and histogram is placed together here.
Okay, that's a good way.
I
I've only ever seen one good example of a stem and leaf plot, and it was in bus schedules in Slovenia. So if you don't remember what a stem and leaf plot is, the stem and leaf plot looks kind of like this. Well, this was the one that was in Slovenia that I thought was kind of cool. Not that I was in Slovenia, but it happened to actually be good. So all the stem and leaf plot is so you don't have to keep writing out the same numbers. So this is 701, 705. So also in the stem and leaf plot, you can have the same number repeated. Okay. That's what stem and leaf plot is.
It's 11, 11?
Yep, 11, 11. And there's two buses that leave at the same time. I thought that was kind of cool. I think weird stuff is cool.
I read it, but I don't get it.
Oh, you get it now? So
I mean, I know what you wrote it, but here they have like so many different things.
no, yeah, well that's why you can get the information in one of 4 ways. So you can get it from reading the book, taking the exams, listening to me babble, or by actually the activities we do. So you get the information a couple different ways. I recommend the listening to me babble option because, well, I'm babbling. You're stuck here. Listening to me babble. You unfortunate creatures. Okay, so what do we got? We are up to 10. Which of the following defines the ability of a measurement system to divide the measurement into equal data categories? B?
D as in repeated.
Ooh. So repeatability is the result of how your measurement, the variation due to repeated measurements, right? So remembering that in the Gauge R&R study, you're trying to partition your source of variation into one of three buckets, either the variation due to the part, the variation due to the operator, and the variation due to the measurements system, the measurement machine. So the measurement machine, the term for that source of variation is repeatability. The source of variation that is due to the operator, that's reproducibility. So the definitional thing here is resolution. So resolution relates to the ability of your measurement system to be able to resolve, to be able to put the thing into the right buckets.
So the correct answer is B.
B as in boy or burritos or Brandon.
So we don't have this definition in the book.
No, but it is in the slides that I gave you for what? Lesson 5? Lesson 5.
Lesson 5? I couldn't find it.
Yeah. So stability. Stability is what happens when your measurement system doesn't take its lithium.
I'm sorry.
Stability, that's why I say stuff like that, to make sure people are paying attention. Stability is what happens when your measurement system doesn't take its lithium. Stability problems, emotional stability, you got it. You're still looking at me like it. Stability is how your measurement system changes over time. Resolution is what we just defined. Linearity is how your error changes over the measurement scale. So if you have a measurement scale, if you have a measurement system that is 5%, that your measurements are plus or minus 5%, that has linearity problems because your error at, so you have a system that weighs between 100 and 1,000 pounds. So at 100 pounds, you're off by, at 100 pounds, you're off by 5 pounds. If you're at 1,000, you're off by 50. The error is different, thus it's not linear. We talked about reproducibility. So up to question 11. A Greenbelt is comparing two machines against one another to determine if the variance introduced by one machine is different than the variance introduced by the other. Which of the following tests would be used in this application? The F test, yes. Remembering that the F test, yes. I love when you guys do that because I sing and dance up here and you quote it back at me occasionally. Okay, 12. The data that consists of classification rather than measurements is referred to as? Yes, right? Go, no go. 13. Given an upper stack limit of 15.5 and process average of 10.35 and a standard deviation of that, what following statement is true? Okay.
CPK universal minus mean divided by 3.
Okay, so the theory, the exact thing was we guessed.
Yep.
Okay. So let's start with writing what the problem tells us. That's generally a good start. Okay, what are they telling us?
Use 15.5.
Okay, so they're giving,
10.35.
so they're giving us an upper stack limit.
15.5.
Okay, are they giving us an average?
10.25.
And are they giving us a standard deviation?
1.2. This is what my problem is. I get confused. What formula to use?
Okay.
I use 2 for me.
Okay.
And I want the right answer. I'm not right answer, close to that. Right?
Okay.
So it is CU, I think, CU, or
Okay.
it is CPK.
So let's just think about this conceptually. So let's start with CP. Is there a question, CP option? No, CPK itself. Okay, so we over CPK. So what do we need to know for CPK? Okay, so
CPK is minimum of copper minus average.
right. Okay, so do we know the upper specification?
Yeah, 15.5 minus.
Yep.
Yeah, I use
Okay,
that.
so we can absolutely calculate out this guy.
Yeah.
And we don't have, do we have a lower specification of it? Okay, so that's fine. Because we only need CPK allows you to do one side. We still have one of these sides. Okay. So
15.5.
2.5 minus 10.35.
divided by 1.291.
Yep, 3 times 1.291. That's going to be 5.15. And that's going to be 3.5.
It's 1.329.
Is the answer is,
Last one, CPK.
yeah, that's what I thought.
Yep.
I don't even know about ABCD.
Okay, so let's go through. So the answer here was D. Well, let's look at our other answers. Let's see if we can eliminate. You can always guess, right?
No, I can't guess,
Oh.
right? That's the problem.
Okay, so you don't have to guess on this one. So the specification limit is the same as the process limit. Do we know what the process limit is? What our upper or lower control limit is? No. They also don't give us enough information to be able to calculate out our control limits for a control chart. So we can immediately eliminate option A. Option B, the process will produce 2.6% of its output outside the specification limit. Okay, so let's draw a picture. About what we know. We have an upper specification limit of 15.5. And we have an average of 10.35. Okay. By drawing the picture, right, we're going to be producing a pretty good amount of material that is going to be conforming, right? Including this stuff that's going to be bad. That helped us. The process will produce 0.26% outside the spec limit, and the process will produce another small number. So just by drawing the picture, we can't quite eliminate it. Okay. So how many standard deviations away is this? From our mean, our center, to this guy. And it's saying our standard deviation is 1.291. So if we go 1 standard deviation over, right? Or plus 1 sigma. What do we get to? 1.35 plus 1. Yeah, 1.64. Go over another, so that's plus 1 sigma. We go plus another sigma. Where do we get to? 12.99, right?
So you're just adding up the sigmas?
Yeah, we want to see how many sigmas away we are. So we are going to be,
To the
well,
sigma.
and we go again. Again. And again. We're still not there. Okay, we're probably there. Okay, so we're 1, 2, 3, 4, 5 sigma away. So it's going to be a really, really, really small number. So you can go to your Z table in the back of the book and figure out what the exact number is, but if we were at 3 sigma away, what would this area be? Well, I think that's one. Okay, remember our rules, plus minus 1 sigma. What percent of our data is within plus or minus 1 sigma?
Plus minus 1 sigma is 68%. 68%.
Yep, 68, 67, 67, 68. Cool. 2?
25.
And 3?
99.
What's that, right? Okay. So if we're at 3 sigma, and we know it's symmetric, right? So how much is in this tail? If we're at 3 sigma? 0.15, right? Okay. So we know we're 5 sigma away, right? So we can immediately eliminate option B from that, right? And for the same reason, we can eliminate option C. It's going to be a really small number. Getting blank looks. I'm getting blank looks. Okay, so in this case, for the CPK, you had everything you seem to apply CPK. As it relates to the other 2 bad options, when you draw the picture, you see that it's going to be a very, very small number. Your mean is very far away from your specification limits. is in fact 5 standard deviations away. And if it was 3 standard deviations away, you know that there would be 0.15 effective. So you know the number is going to be less than 0.15. It's going to be a lot less than 0.15 because that's a 3 sigma, right? 5. So you can eliminate option B immediately and option C immediately when you just draw the picture and realize how many standard deviations away you are. Because that represents it's really unlikely that you're going to observe a value that's 5 standard deviations away. Cool? You're not cool, but you'll indulge me. Okay. 14 is a question you will not see on the exam. Because it depends what industry you work in. So I'm not even going to give you what the answer was because this question would be chucked out. 15. So for 14, there is no incorrect answer because the question is not applicable to this exam. 15. A plot of data arranged, let me return to that. The reason I leave it in is on your exam, there will be two or so questions that will ultimately not be counted. Because you will get a comment card at the end that will say, hey, I object to this question. I think there was 2 right answers or I think there was no right answer. You will get that on the real exam, and my experience of doing this for a couple of years is that there's only 2 questions on there that people have a point on. The way it works, the psychometricians, the guys who make the test, if more than 2 or 3 people object to a question, they'll actually review it. And they'll say, is there actually a problem with this question? So this would be an example of a question to object to because there is no right answer. Well, there is, but it depends on what industry you're in. So if you put D, that would be the one I would have put, but that actually is not the credited answer. So let's go on to 15. A plot of data arranged in time sequence is a yes. So that's exactly what a run chart is. It's just a plot of data in time sequence. So many of your control charts are actually examples of run charts. And yes, I did just run across the carpet. 16. A histogram can be used for which type of data? Which types? Type or types? Yeah, histogram, you can use it on all types of data, right? You can do a histogram just easily on yellow versus blue, or as you can do as 1, 2, 3, 4, 5, 6. Cool. 17. Check sheets can be used to collect. Can you write yellow on a check sheet? Yeah. Can you write a number on a check sheet? Yeah. So check sheets can be used for both. Yeah. 18. Accuracy error in measurements is also referred to as bias. Got that one wrong, it's a crime. Okay. If 2 processes have the same value of CP, but the process 1 has a CPK value of 1.33, and process 2 has a CPK value of 0.67, what can be said about the process? Okay, so A is wrong for the same reason we discussed with you earlier, is that process capability does not relate to control. Before you can even do process capability, you have to establish that your process is in control. Because the idea of control relates to predictability. So if I observe my process today, is it a good prediction of what I will observe tomorrow and the next day? If you have all of these weird things happening, all of these special cause variations, well, you don't know if you're going to see that weird thing. You don't know if your buddy's going to shout out that expletive in the middle of your downswing when you're golfing. You don't know if that's going to be there. So you're not, if there's all this special cause variation, all this assignable cause, indicating your process is out of control, you can't even get to the point of process capability. Okay, so it's not A. B, the process is not capable, but the second isn't. Well, a 0.67 process capability might be adequate for your particular circumstance. It all depends on what you're doing. When microprocessors, when Intel introduces a new chip, they would know what their yields are? About 13%. So when Intel introduces the new computer processor, 13 out of 100 make it in the box. 87 out of 100 end up in the trash can. And that's good enough to keep Intel in business. I used to be able to say AMD, but AMD no longer makes chips, they just design them. Full disclosure, AMD is a client. Okay, the first is centered, the second isn't. Okay, that seems like an interesting answer. We know that there's a difference between CP and CPK that relates to centering, right? And what do we know about? When is CP equal to CPK? Yeah, when the mean of the process is directly in the center of the spectral limits, CP and CPK will be the same. Okay, so let's look at the fact pattern gives us. Okay, if two processes have the same CP, and one has a CPK value of 1.33, and the other has a CPK value of 0.67. No, we don't know about capable.
No, we can only say centered and not centered.
Yeah, we don't know about capability because it is capable because that relates on to what your industry is, what you need your process to be. You need extra information. So centering we can talk about, right? So if CP and CPK are the same, process is centered. If they're not the same, they're not centered. We also know that CP by definition has to be higher than CPK. Okay, so we know that D is wrong. Everyone see why D is wrong?
Because of the CPK value 0.67.
Yeah, because we know the CPs are the same, but we have one CPK being 1.33 and one being 0.67. So that means that at least one of them isn't centered. And we know it's process 2 because CP has to be higher than CPK. So our answer is C. Just remember that CP has to be greater than CPK. CP represents the best possible scenario that you're perfectly centered in your specification limits.
CP has to be greater than CPK for what?
Because it represents the best possible circumstance, the best case scenario, that your process is perfectly centered between your specification limits. A plot of one variable versus another is a scatter diagram. Yes, for us scatterbrained individuals out there. So we know what a control chart is. A control chart is the chart that allows us to identify the extent of the common cause variation and differentiate special cause variation. Special cause variation being that weird stuff that has assignable cause. Scatter diagram was the answer. Box plot is the box and whisker thing where you have the bottom of the box being the first quartile, center of the box being the median, second quartile, third quartile, and the top and bottom of the whiskers representing your extreme values. And the stem and leaf, I just threw one of those up there. Okay, 21. An important step that must be completed before a process FMEA can be constructed is to exactly. Well, we didn't get to FMEAs yet, but what the purpose of a failure modes effects analysis is to look at your possible failure modes, how your process is going to break. Well, A is the point of an FMEA, and we're talking about stuff you're going to do before the FMEA. So that's kind of your output is A. C is part of the steps of doing an FMEA is calculating out your risk priority number. And the risk priority number, okay, when we get to FMEAs, is the occurrence. So how likely does this failure happen? Multiplied by your severity. So if someone dies, that's really important. If someone gets a paper cut, no one really cares. And then that's multiplied by your detection. So detection is how likely is it that this defect is going to sneak out there and be found by your customer. So that's how you calculate your RPN, but that's what you do in an FMEA, so that can't be the answer. And prioritize the failure modes for a later action. Again, that's what you're doing in the FMEA. And this question is asking you for what do you do before an FMEA. So the answer there was, yeah, B. Define what the process is. 21. That was 21. 22. During the process of trying to discover causes for field failures, a review of the individual and summarized data should include a Pareto? No, the answer here is a Pareto chart. Remembering that's the ranked histogram. The purpose of doing a Pareto chart is to be able to determine the critical few from the trivially many. Generally, here's our failures, and these are the causes that are causing the majority of our failures.
It's a pinhole in the jug exam.
The pinhole in the jug, exactly. Someone's been practicing their old exams.
Remember that.
Cool. 23. Which Six Sigma team member is primarily responsible for removing the barriers to team success? Yes! Farooq Basara would appreciate that answer.
Who's that?
No one?
Who?
Farooq Basara. You know who Freddie Mercury is?
Which one?
Freddie Mercury,
Where do you agree now?
lead singer of Queen. Since we are the champions. The lead singer for Queen was born on the island of Zanzibar, and his birth name was Farooq Basara. And yes, you should have known that, because, well, I knew that. Yeah. It was funny to me. It's about entertaining me. Okay. 24. A population of 12,000 units has 58 defects. What is the DPMO? Defects per million opportunities.
I think you got the answer right.
Everyone got the answer right? What was the answer?
It is C, yeah.
Okay.
Defects per
Million.
population.
So it's defects divided by the opportunities times a million.
That's million.
Yeah. So the answer was C.
You know what? I didn't type that page.
25. A significant difference between the process capability, CPK, and performance capability index is okay, I'm starting eliminating answers, right? So let's work from the bottom up. CP and CPK can be used even if the process is out of control. Absolutely wrong. You can only do process capability if your process is in a state of statistical control. So that one's absolutely wrong. C, PP and PPK can be used when the distribution is not a normal distribution. Have we talked about anything that is not normal in this class? No. That one's wrong. For the same reason, B is wrong. And the answer is A.
I just checked the formulas.
Okay, that always works. 26. The sequence of behavior typically observed in a project team. This is about the Tupman cycle. Yes! Right there with the Tupman cycle. 27. An FMEA is being constructed for the manufacturing of a syringe cartridge. The team has developed a risk ranking analysis scale for calculating the risk priority number. The team has assigned 5 values for ranking the likelihood of occurrence, 10 values for ranking the risk associated with the severity, and 5 values for ranking the risk associated with detection. Using this method will most likely result in
Chose D. Chose B? No, D as a dog. Yes.
okay, let's look at A. A is not the answer, so don't be concerned. Ensure that all values of occurrence, severity, and detection are equally represented in the RPN. No, right? We saw that we're giving 1 on a 1 to 5 scale, well, 2 on the 1 to 5 scale, and on severity, we're giving on a 1 to 10 scale. So the severity is going to have a disproportionate weighting, right? It can be, twice as powerful, twice as important. Give severity a disproportionate representation in the RPN. Well, that's kind of what I just said. C, give occurrence and severity an equal representation in the RPN. No, well, we gave one on a 1 to 5 scale, the other's on a 1 to 10 scale. And D, ensure that RPN reflects the priority for addressing failure modes. Well, it doesn't ensure that. It just, no. So the answer is B, because B is right. D is kind of not quite.
Give severity.
Yeah, because severity can be on a 10 scale. So if you think it's the most important, if you think it's the worst, it's going to get a 10. What? Well, you can get 20. You can get 24 wrong. Actually, on this, you can get 100 wrong. Doesn't really matter because the only score that matters is your score on the June exam. And the best way to get better on the June exam is to keep practicing going through these and drill through them, just so you can remember the pinhole example for the Pareto chart. Okay, what are we up to? We're up to 28. In a team environment, who is primarily responsible for identifying and resolving negative behaviors? Somebody. Yeah, somebody. That's a good answer.
Manager or leader, somebody.
It's the manager.
It's a manager?
Yeah.
It's a manager.
Those of you who are managers, you probably spend a disproportionate amount of your time dealing with that problem.
Why not leader?
Because the leader is generally above that. They're not handling that day-to-day operations. That generally doesn't bubble up. Think of the site lead here. So you would involve the site lead on two of your teammates figuring
So
with each
leader
other.
is not like the area owner?
It can be the process owner, but you generally have the frontline area. So you have the frontline management team, but you have someone who's responsible for writing reviews or draft on.
I said leader. Okay.
So the leader is generally on a more of a larger scale. 29. What are the benefits of a QFD, the quality function of deployment, the house of quality, that thing that translates the what's into the hows? And it gets me to do real cool things, I guess. The product objectives based on customer requirements are not misinterpreted. Yes.
You said D.
I didn't say anything. I just read the answer.
No, I have a D, so
Okay. So I think I'm D too.
So 1 is good, right? Eliminate control points.
What is that?
Product, what's QFD?
So eliminate control points? What is that?
I don't know. It's not right.
Okay.
And increase efficiency. So the answer is D, 1 and 3.
I'm not using control point in a QFD and
I can saw the definition and try to see things.
Yep. 30. Which of the following quality management tools best helps teams break down project activities into smaller actions necessary to obtain the project objectives? The tree. Yes, that's where you start with the big problem and make it into smaller and smaller problems. Remembering that the activity network diagram
I'm
is
confused between that.
Well, the activity network diagram is a project scheduling tool. So it allows you to lay out a project and see how the tasks relate to each other. That's the activity network diagram. Then there's the affinity diagram. The affinity diagram is where you put the ideas in Post-it notes, you stick them up on the wall, and then you push them, then you categorize them, you create a header card, and you group the ideas based on some sort of word nominal values.
But that also has break down the movement, isn't it? It doesn't break down the ideas, probably.
Well, it's not breaking it down. It's just brainstorming. It's trying to flush out a lot of ideas. The interrelation diagram is where you have your ideas and you study the relationship between those ideas. That's the interrelation diagram. And the tree diagram is the brainstorming tool where you break a problem into smaller and smaller problems. So the answer there is the tree. 31. When first established, team members go through a period of team growth, often referred to as forming. This stage typically includes the following behaviors by team members. Well,
Sounds A good, right?
I think D.
well, this is the forming stage, right? Remembering this is sort of the honeymoon
That's why
phase.
people argue.
No, you're not there. The storming phase is when you argue. This is when you're trying to win over the girl. This is when the relationship is new.
See, that answer is so close. I picked the same one.
Well, it really goes back to your romantic relationships. It starts off really good. Everyone loves each other. You don't want to argue with the person. You just kind of want to bask in the aura of being with the person.
Then it should be C.
And then-
I was like confused.
And then you hit the storming phase where stuff starts to sort of get on your nerves, right? And you start to butt heads. You start to try to work on stuff together, and it doesn't even. And a lot of relationships end there. And then the more successful relationships, you get through that. You start to get into the norming phase where you get to actually start to come to a consensus. Then you hit your stride and you're performing, and then you're good to go. So if you're related, at least it works for me, if you're related back to that idea of a romantic relationship, starts off, not much work gets done, but everyone kind of feels good. Then you start to try to get some work done, and heads start to butt, and there's some friction. Then as you work through that, you start to come to an understanding of roles, responsibilities, and then you hit your stride, and then you start getting some stuff done. What are you saying? Romantic relationships, you can't get anything done?
The answer is C.
Okay, so it's not arguing. It's not questioning the wisdom. Attempts to define the task and how it will be accomplished. That sounds okay. Establishing and maintaining team ground rules and boundaries. So I'm down to those two, right? So who put C? Who thinks it's C?
I think now it is
I would both A and C.
Well, it's not A. You're not arguing yet. You're not to the arguing point yet.
A, but now with the explanation, it makes more sense to see.
Yeah, the answer is C.
Excuse me. Sorry.
Okay, we're up to 32. Peter, back to pins. Question. Hey, we still got 3 minutes. You can leave. No one's holding you. You're not change your chair. I will at least read the question. A total of 5,000 pins were packed by Peter. Were manufactured on the machine. 200 pins had a total defects of 600. 4,800 pins were packed. At the end of the line, what are the defects per unit and throughput yield for this process?
I got B.
So
I
how,
don't know how to count 89%.
okay.
So it's like 600 divided by 5,000. So it's
Exactly.
0.12.
Yep.
But I don't know how to
And then
count
the
89%.
throughput is
Throughput yield.
Throughput yield.
E to the negative dp.
Yes, ma'am.
Function E.
The gentle lady has it.
So what is that? Say it again.
E, so function E on your calculator, raised to the negative dp.
And did the gentle lady find that in the book, or did she?
Yeah. Yeah, page 67 and 68. I think, or 60. Sorry.
See, the answers are in the book. You just have to look.
And where's the page 67?
It's like in small text. It's like on the opposite page.
Oh, it's in a legal font, right? So you can't read in legal fonts. We will pick up there. We'll actually move.
Oh, it's on page 68. Isn't it?
We will go over that question.
It says total throughput yield, but you're talking about the formula?
Yeah.
Mhm. Yeah, it says, under where it says roll throughput yield, look like 3 lines down.
Oh,
It
yeah,
says throughput
Oh,
yield.
yeah. Here it is.
So then Q equal to what? Or these units?
Yep. Natural base E to minus DPU.
Yeah, it's the third line.
Total number 4.
Yep.
E.
Cool.
Somewhere.
So we'll pick up with that one. We'll walk through it. The answer was B.
Here.
So that was one, then E.
So
Two.
E.
Seeming hard
to
still?
the negative.
No, but somebody says it.
Oh, come on, guys.
I got it. Actually, not going to say it.
Well, you got 14 weeks.
89.